Diode current equation. In PN junction diode, what is the total current equation? We can find it from this derivation. From law of junction, we know that Pn of 0, that means holes concentration in n-type in n side of depletion region at 0 distance is equals to Pn naught, that is hole concentration in n side region at open circuit condition into e power V by Vt, where V is the applied voltage and Vt is the voltage equivalent of the temperature. Now, the difference between the two concentrations of junctions under biased and unbiased condition. This is open circuit type and this is biased type at 0 distance. The difference is called injected or excess concentration, that is capital Pn of 0. Pn of 0 is equals to, in this place I know the formula Pn naught into e power V by Vt. If I substitute Pn of 0, then I get simplified equation Pn of 0, that is injected or excess concentration is equals to of P means what? Holes. N means what? N-side, N-type semiconductor. Hole set N-type semiconductor at 0 distance from junction is equals to Pn naught, that is when no bias, that is when open circuited holes in N-type region into e power V by Vt minus 1. Similarly, if I want to consider the electrons, N-type means electrons in P-type region, N means electrons, P means in P-type region, 0 means at a 0 distance away from the junction. The concentration will be Np naught, that is the electrons concentration in P-type region when the circuit is opened into e power V by Vt minus 1. If you watch the concentration of Pn in PN junction diode, we have in junction, particularly consider junction, we are having in P-type material, we are having a high holes concentration. In N-type material, I am having low holes concentration, so the concentration gets decreased based on the distance we are considering. Here it will be Pn0, that is open circuited holes in N-type region. This is Pn of 0, that is holes concentration in N-type region at 0 distance. Now, the whole current, the current due to holes, that is whole current crossing the junction from P side to N side, is Ipn of 0 is equals to AQ dP by LP into Pn of 0. Similarly, the electron current crossing the junction from N side to P side is given by INP is equals to NP of 0 is equals to AQDN by Ln into NP of 0. So here A means area and Q means charge. A means cross section area of the junction and Q means charge, that is 3 in 10 power minus 9, and dP means the diffusion constant for holes. Similarly, Dn means diffusion constant for electrons. And Lp is diffusion length for holes. Ln means diffusion length for electron. Now, coming to the total current passing through the junction is equals to sum of current flowing from P side to N side at zero distance plus N type semiconductor to P type semiconductor. The total current flowing at zero distance. So if we sum the above two equations, then we are going to get this as like this. Multiplied with e power v by vt minus 1. And after simplification, I is equals to I naught into e power v by vt minus 1, where I naught is reverse saturation current, that is IPN of 0 plus INP of 0. Equation 7 is required to express from is the required expression for the diode current. This equation is derived without considering the carrier generation and recombination in the depletion region. If we consider generation and recombination of the carrier in the depletion region, the general equation of the diode is approximately given by is equals to I naught into e power v by eta vt minus 1. I is diode current where eta is a constant, that is for germanium it will be 1, for silicon it will be 2. I naught is diode reverse saturation current at room temperature, and V is applied voltage, that is battery voltage that we have applied for the PN junction, and Vt is kT by Q or T by 11,600 volt equivalent of temperature, that is thermal voltage, where K is the Boltzmann constant, that is 1.38 into 10 power minus 23. Q is the charge of an electron, that is 1.6 into 10 power minus 9 coulombs. T is the temperature of the junction at degrees Kelvin.